Hi everyone and welcome back to Dev Portal. In today's session, we are exploring one of the fundamental concepts of PostgreSQL, the data types. Understanding data type is critical because they determine how data is stored, processed and queried. Choosing the right data type impacts database performance, data integrity and storage efficiency as well. So let's dive right in. So the question arises, why data types are important? Data types define the kind of data that a column in a table can hold, like number, text or dates. They are essential for preventing invalid data entry, and using appropriate data types we can save space as well. And it will improve query execution time by aligning data types with use case that we have. Postgres offer a wide variety of data types categorized as follow. You can see numeric data type is there, character, date and time is there, Boolean, and some other data types are also there. In this tutorial, we are going to discuss some of the most used data types that we are using in the project. So first let's start our discussion with the numeric data types. These are used for storing numbers including integers, decimals and auto-incremental values. If we talk about integer and BIGINT, then the purpose is to store the whole number. Integer is suitable for standard size integers like age or count, whereas BIGINT is used for very large numbers such as population data. If we talk about numeric, then it stores exact decimal values ensuring precision. These can be used for financial applications requiring exact calculations such as salaries or tax rates. If we talk about serial and big serial, then these are auto-incrementing integers commonly used for primary keys. Serial automatically generates unique value for new row that is inserted, whereas big serial same as the serial but it supports larger numbers. Character data types are ideal for storing textual data ranging from small fixed length string to large variable length text. If we talk about char, then it is a fixed length string padded with space if the input is shorter. What does it mean? Suppose if you have created a char for states of 2 size, then it means if you are saving C as a value, then it will add space after C and then it will save in the database. And if you are going to save CA, then it will store data as it is. But if you are trying to give the number which is exceeding the limit, then it will give the error. Whereas varchar is a variable length strings with defined maximum length. And text will be used for unlimited length string suitable for storing large blocks or text. Date and time data types are used for managing temporal data like dates, times or timestamps. If we talk about date, then it will store date only values, means we can use it for appointment dates or project deadlines where we only need to save the date. On the other hand, time will only store time only values and it will be used for time specific data like meeting schedules or operating hours. The timestamp store both date and time values and it can be used for logging events with precise date and time. Boolean is used to store true-false values, often for flags or status indicators. It will store 3 values, true, false or null, and we can use it for flags for status like is active, is verified or is admin. Postgres supports advanced data types for complex scenarios such as BYTEA. It stores binary data like images or files, whereas we have JSON as well to store JSON object, and then we have array to store array of values. It can be used for multi-valued fields like tags, categories or keywords. Choosing the right data type is crucial for our application. So these are some scenarios that we can consider, like we can go for integer or BIGINT for numeric values. We can use varchar for flexible text with predictable maximum length. Text can be used for fields with unrestricted lengths, and we will always prefer date or timestamp over storing dates as a string for better querying. Now it's time to discuss some of the performance consideration between char, varchar and text. First let's talk about the storing efficiency. Postgres stores data differently for char, varchar and text, impacting storage space and performance. When it comes to char, then it is a fixed length string. If the value is shorter than n, Postgres pads the remaining space with blanks. This ensures consistent storage size but wastes space for shorter values. Here we have created one table which is countries and we try to save the country code with char 3 It means maximum it can store 3 characters. Now if I try to insert two values, that is US and IND, that is India, then US will not store as US only. What it will do, it will add one space after S and then it will store in the database, whereas IND is added as it is with no padding. So what impact it will create? Padding increase storage size unnecessary when data is shorter than n, leading to inefficiencies in queries and updates. If we talk about VARCHAR, then VARCHAR is a variable length string with defined maximum length. It dynamically allocates space based on the actual length of the string. Here we try to save Aman and Harshada as a string, and you can see that Aman will use only 4 characters of storage and Harshada will use only 8 characters. That is the length of their strings. So what will happen? It is more efficient for variable length data since no padding occurs, and it will save storage space for shorter values compared to char. When it comes to text, there is a no length constraint. Store strings as any size. It is ideal for storing long and unstructured text. Here you can see in the example we try to create one table as an articles, and we have given content as a text, and it can save any length of text as a value. So it will lead to only the actual data is stored with no padding, and it is suitable for fields like comments, blocks or descriptions where the length is unpredictable. What impact it will generate, that we will discuss in the next slide. So now let's discuss about indexing. So as we discussed, since text fields have no length constraint, indexing them creates larger index compared to VARCHAR. Index for text field can become massive, especially for longer entries. This increases the time of index maintenance and lookups. Whereas VARCHAR, restricting the length with n characters, creates more controlled and smaller index size. And smaller index size makes query lookups faster compared to text for longer strings. It also improves index maintenance during updates and insert. If we talk about char, then padding in char can add unnecessary storage to index, increasing the index size. Now let's discuss the use case of all three data types, that is char, VARCHAR and text. Char is a fixed line data where all entries are expected to have the same size, so we can use it for country code or pin code, where padding ensures consistent storage size, which may simplify certain fixed length operations. Whereas VARCHAR is variable length data with predictable maximum length, so we can use it for first name, last name, where we don't know how many characters will come, but we can predict that will be the maximum size. It is dynamically allocates space for each value, making it efficient for fields with variable length entries. When it comes to text, then fields with higher variable or unlimited lengths we can go, like block content, product description or user comments. It allows for unrestricted length, making it suitable for unstructured data. However, avoid overuse of it as it can lead to larger indexes and slower queries. This is the performance comparison between the char, VARCHAR and text that we have already discussed in the previous slides. Choosing the right data type not only ensures efficient storage but also helps maintaining database performance over time. Each tutorial notes link I will give you in the description, as well as that note link I will pin in the comment section, so you can go through it for your theoretical knowledge. In this tutorial, we have explored why choosing the correct data type is essential for database performance, and a dive deep into PostgreSQL, Numeric, character, datetime and other data types. The difference between char, VARCHAR and text we have seen, along with their performance impact. By understanding data type, we can design effective, scalable and reliable databases. In the next tutorial, we will dive into creating and managing tables in Postgres, applying these data types in practice. So please stay tuned, like this video, subscribe to Dev Portal and share it with your fellow developers. Until next time, happy coding, and I will see you in the next video.